Positively Perfect Problem Solving presents literal equations. Literal equations are an extremely useful thing, especially in science. In science, we have a lot of formulas we use, like area is length times width, and perimeter is twice the length plus twice the width, etc. We have lots of equations to use. So literal equations are useful in that we can pick what we want to isolate and then solve the equation for that specific variable. So I'm going to show you what I mean by that. So let's take a look at these two equations right here. I've got the one on the left that says 5x plus 2 equals 33, and the one on the right has no numbers whatsoever. And most literal equations won't have numbers. You're just going to be moving kind of letters around. So if in the first equation I want to solve for x, so I want to try and get x alone. That's what I mean by isolating it. We would solve this like you normally would. You would draw your line, and your first step here would be to get the x by itself would be to subtract the 2. That's our first step. Our second step then would be to bring the 5x down and then actually compute what 33 minus 2 is, which is 31. So on this right side, I still want to solve for x, okay? I want to get this guy alone, get him alone. To do that, I have to get everything around him on the other side. So just like on the left side, how I got rid of this 2, on the right side, I'm going to do the same thing, but instead of getting rid of 2, I'm actually going to get rid of b. Now I know this is weird, but if I want to get rid of b, if I want to get rid of 2, I subtracted 2. If I want to get rid of b, I have to subtract b. If I subtract b here, I also have to subtract b here. And now here's where things get interesting. Notice on the left, when I subtracted the 2, I could actually compute that. 33 minus 2 is 31. However, on this side, c minus b, that's not a thing. Like I can't take c minus b and get a different letter. C minus b, I don't know what that is. So the best I can do is just rewrite it as c minus b on the right side, instead of actually computing it like I did over here on the left side. Now here on this equation, I'm just going to bring the ax down. So ax now equals c minus b. It's the same thing, instead of 5x, it's ax, and instead of 31, I have to just write down the c minus b. The next step we have here is on the left equation. If I wanted to solve for this, I would divide both sides by 5. And the 5 would go away, and I would get x equals 31 over 5. We've talked before about how getting fraction answers is a thing, and I mention that because on the one on the right, I still have the exact same step. Instead of dividing by 5 like I did over here, I'm actually going to divide by a, because I'm trying to get x alone, and that's the only way that we'll get it alone. Okay, now since I divided by a on this side, now here's the weird part. You have to divide the whole thing by a on that side, because remember that c minus b is the same thing as the 31 over here, and I divided that 31 by the 5, so that means that c minus b all has to be over a. Okay, so my final answer, and this is very strange to have for a final answer, but your final answer in a literal equation ends up being your variable you're solving for on the left and then a bunch of letters on the right in the correct place and order. Okay, so whereas the one on this left had your answer as an actual number, the one on the right will be letters, because you have to start with letters and you can't simplify letters. Okay, literal equations are very strange. And just going forward, I want you to know that they are very strange. Okay, let's do a second example here. I've set up 2 very similar problems. So here I'm gonna show you what you do on either one. So on the left one, remember, I taught you guys to get rid of fractions first. And this is really important here. So we talked about getting rid of fractions first, so I have this 2 that I have to get rid of. So if I want to get rid of the 2, I have to multiply every single thing by 2. Okay? That means that these 2's cancel out, and I have x plus 5. 2 times negative 7 is minus 14. and then 3 times 2 is 6. Okay. So similarly, on this side, I have b as a fraction. So now I'm going to multiply everything by b instead of by 2. So everything gets multiplied by b. The b's cancel out. I'm left with that thing on top, which is x plus a. And then b times c is just bc. I can't actually calculate that, so I just rewrite it. And over here, b times d is just bd. Okay. Now, our second step. Now I want to try and get the x by itself. So there's two things I can do here. On this left side, I could do 5 minus 14 and get negative 9. I could do that. So I could get x minus 9 equals 6. Or, instead of doing that, I could subtract the 5 and add the 14 over and get the same thing. Okay, so once I complete all of this, I get x equals 15 over here. Now the problem is that over here, the a and the bc are not like terms. I can't combine them like I did with the 5 and the 14 over here. However, I know that I want to get x alone, so I can just I can add the bc to both sides. Get rid of that. It's okay that I'm adding this. This is a term. I know it's two things stuck together, but I can add the whole thing over. So I'm going to get x plus a, because that's what's left over, equals, now bd and bc are not like terms. So I just have to write them, bd plus bc. And then the last thing I have to do for my last step is to subtract the a. Let's use a different color here. These cancel, and I get x equals bd, oh, put the minus a here, bd plus bc minus a. Okay, I know this looks really terrifying. I'm very aware that you want your answer to just be, okay, x equals 4, I'm done. But the point of literal equations is that let's say that I've got, the actual point of literal equations, if I have a area here, and I know that this area is 40 and I know this is 2. I know that this has to be 20. I know that because I can see a picture. But let's say that I have got my formula, I've got area equals length times width. And I know that one of the sides, I know the area is 40 and I know one of the sides is 2. Okay? I can go ahead and just divide both sides by 2 and get the 20, but instead, what if I took my area formula and divided both sides by that length to start off with, and then I get that width is area over length, and now I can just plug in the area and the length automatically without having to do an extra step. Okay, and this becomes much more important later on when you take chemistry, when you're dealing with like 5 or 6 variables instead of just length times width. Okay, but rearranging a formula is really, really important to make life easier. I know right now it seems like this is really hard and why are we doing it, but later when you're older in high school, and if you go into a career in something that has any kind of scientific formula, it's going to be really helpful. Okay. The tricky part about this as well is really paying attention to which variable you're solving for. So I mention this because the directions really do matter. They matter a lot. So in this particular problem, they want me to isolate x. So they want me to get this x by itself. Okay. So that means everything else has to go that's around it. I don't have any fractions, so I can start getting rid of things. However, I do see parentheses, so I'm going to go ahead and distribute that out. So I get 2x minus 2h plus k equals 8. Now these three things aren't like terms, so I can't really combine anything. I want to start getting the x alone, so I'm going to go ahead and first add the 2h over. Those cancel out, and I have 2x plus k equals, now be careful, this is not 10h. 8 doesn't have an h with it, they're not like terms, so this is 8 plus 2h. You just have to rewrite it. Okay. The next step then is to get rid of the k. So subtract k on both sides. They cancel, and now I have 2x equals, none of these are like terms. So I have 8 plus 2h minus k. Now the last step is to divide everything by 2. Now there are two options here, and I don't care which one you do. I really don't. So I'm going to put an or here. So I'm going to write these in two different ways. I would take either answer on a test or quiz. There is a better one, but for right now, I don't care which one you do. The first option is to just divide everything by 2 as a whole. And what I mean by that is I'm dividing everything by 2, and you just do that. And you say that your final answer is x equals 8 plus 2h minus k over 2, and you're done. Okay, that's one way to finish this problem. The other way, and I'm not sure what they'll want later, but is to divide every single term by 2, which is really the same thing. That's really what you're doing. So what your final answer then would look like is this would cancel out, and you'd have x equals 8 divided by 2 is 4. These two cancels out, and you get plus h, and this becomes minus k over 2. Now, if that is confusing to you, then do the other one. I don't care, both of these are equivalent, okay? It doesn't matter as long as you understand the order of operations and undoing these equations to get the variable that it says to get. Okay, so I'm going to show you 4 more examples, and these examples are all formulas that we use in science or math in some way. It's not just random. The first one is the slope-intercept form. We're going to see it a lot later. That was the bell. Okay, that's not your bell, that's the bell in the video. Okay, so this is rearranging the formulas. Rearrange just means solve for that variable. So this is slope-intercept form, and they want you to solve for m. So I'm going to go ahead and highlight m, or just draw over it. That's not my highlighter. Let me actually find my highlighter. There we go. Highlight m, and they want you to highlight m here. So I'm going to draw my line, down my equal sign, and start getting m by itself. So to do that, I want to get rid of b first. The b's cancel out. I get y minus b equals mx. Notice I can't do anything with that. I can't combine them. I can't put them together. They just get rewritten as y minus b. Okay. Now I want to get m alone, so I'm going to divide both sides by x. The x cancels out, and I get m equals y minus b over x. Okay, you couldn't rewrite it. You can say that m equals y minus b over x if you want to be fancy. Get that variable on the left side. Okay, again, you're not really doing anything but rearranging. You're not making it smaller. You're just rearranging it for the given variable. Okay. This is an interest formula. Okay. We use this a lot in banking and in calculating interest when you invest in something. It's interest equals principal rate and time. So I want to solve this for t. So I know my variable is t. So this one's a very simple one. The p, the r, and a t are all attached using multiplication. So to undo it, all I have to do is divide. Okay, that division cancels out the p, cancels out the r, and I'm left with time equals interest over PR. One simple step, and I've rearranged this formula. Again, you can rewrite it as this. Either way is okay. Keep in mind, when you're writing t's, just a heads up, please make it have a little hook on the end. If you don't, it looks like a plus sign. It's very confusing. So do you see how in the font it even has a little curl to it? Please do that. It's going to really help you out and help me read your work better. The last two, number 3 is area equals 1/2 base times height. That's a triangle formula. So now I want to solve this formula for the base. So like normal, I'm going to put my line down the middle, and I'm going to get rid of that fraction first. So I'm going to multiply both sides by 2. Now because the 1/2, the base, and the height are all attached by this, the 2's just cancel out, and I don't have to worry about the b and the h. On the left side then, I'm going to have 2a equals b and h. And to get rid of the h, I just divide both sides by h. and I get 2a over h equals b. Again, if you want to rewrite it, you can, but you don't have to. It's up to you. Okay, and lastly, this one looks terrifying. I know in your mind you're thinking, oh my god, please make this stop. I hear you, I understand. But it's not that bad. I want to get h by itself. Okay, remember my rule, always get rid of fractions first, no matter what. So we're going to draw our line. To get rid of that fraction, we're going to multiply everything by 2. So this is where things get weird. This guy, this a plus b in parentheses, this is attached here, and it's attached here by multiplication. So even though I see a plus sign, everything is actually attached by multiplication. Okay, I know you don't believe me, and that's okay, but trust me, it's all attached with multiplication. So if I multiply by 2 here, I don't need to multiply by 2 anywhere else but on the other side. Okay, that's what makes this problem a lot easier, is I don't have to worry about that stuff in parentheses. So if you've got stuff all jammed together with one set of parentheses, then you should be fine. Now, if this said something like this, 1/2 a plus b, and then it said plus h, that's a different story. We'd have to multiply by 2 here, and then we'd have to also multiply by 2 here. But because this h is attached right next to the parentheses, you don't have to worry about that. There's a big difference between what those two things look like. So now that I've multiplied by the 2, this becomes 2a. This is all gone, goodbye. And I've got the a plus b times h. I want to show you guys a trick, but I don't know if I should. Actually, I'm going to show you the trick, so I'm going to write it over here. It's kind of a cool trick. I like to give you guys options. Some of you may like this trick. Some of you, this may be confusing. You don't want to do it, but I'm going to show you anyway. So there's 2 different ways to now go from here. The one way that you guys would know is to distribute this h. Let's do that. So I'm going to do AH plus BH, and now I've created a problem for myself. I've created a problem for myself because now I've got H in 2 different places. That's the problem. I've got an H here and an H here. The whole point of this problem was to get H by itself, and now I've somehow duplicated H. I can't combine the AH and the BH because they're not like terms. And if I subtract one over here, I got 2a minus, oops, that's a equals. 2a minus AH equals BH. That doesn't help me. I've still got these H's everywhere. So, this makes me angry. So there's got to be a better way to get H by itself. Well, that brings me to this thing over here. So because this is attached with multiplication, this is a sneaky, sneaky trick. I can actually divide this whole thing by the a plus b. It'd be like saying if I had 10 equals 2h, I could divide both sides by 2. It's like saying that a plus b is the same thing as that 2. That's what is happening here. So just like the 2 cancels out here, the a plus b will also cancel out. And note, I have to divide both sides by that, so both sides get divided by that thing. Okay? So I can do it, I just can only do it with this method. This guy didn't work, and it's very sad that didn't work. Okay? But we can still mathematically make it happen. This will be the hardest kind of one you'll see. Okay? So your final answer here would be 2a over a plus b equals h. Okay. Literal equations are hard. They're hard for me to teach. They're hard for students to learn. They are a huge struggle. You know, I want you guys to take your time, like always, with the practice. And if you get frustrated, I really want you to come ask for help. I say this every video, but so many of you sit and stare at your work hoping it magically comes to you, and it just won't. It doesn't work that way. So I'm not always the best at explaining things, but I'm here to try, and you can ask me as many times as you want, and I'll always have the time to help you. So good luck, and I'll see you in class.